Hi, I'm Bryce Grunert from Michigan Technological University, and I work with Colleen Mao at Rhode Island. I presented yesterday, but if anyone has any questions, I'm happy to talk about it. Just come find me. So I'll talk to you briefly about optically estimating CDOM composition across diverse spectral ranges. Typically, CDOM is fit with an exponential function. That top, nope, that is not the right button. So,
yeah, I'll help you.
All right. Which one's the laser pointer? The middle? Okay, all right. So typically the blue line is a standard exponential fit. The black line is the actual data. This is an absorption spectrum from the Chukchi-C. And you can see that there's these deviations here around about 280, 290 nanometers, and then another smaller one around 425 nanometers. And so what we did was we fit those with Gaussian components, so Gaussian peaks, to get a sense of what specific chromophore was in that region of the spectra. And so when we aggregate all the absorption peaks that we fit throughout the global ocean in the upper photic zone, we see that there's a common frequency around, this is about 425 nanometers, and that's a chromophore that's produced in situ throughout the global ocean. There's another peak around 375 nanometers. That's a photorefractory chromophore. And then down here, this is the lignin peak. And so you see that it actually shifts as it photodegrades from inland waters out to the open ocean. And over here, what we want to do is we want to first compare the two methods. And so you can see that throughout these different Longhurst provinces, there's typically a pretty small change, about 0.001 per nanometer. But some of these open ocean regions, if you fit between 300 to 700 nanometers, you get changes up to about 0.002. So not very significant change in that slope parameter, which can give you information about CDOM composition, but getting a little more information by fitting these specific chromophores. And so we consider these different slope ranges because they give you a different sense of what's there. And they vary pretty significantly throughout the global ocean. So what we then want to do is quantify how does that impact estimates from satellite remote sensing. And so what we did was we considered a standard slope that would be used in a satellite algorithm of 0.0154. And so we took the mean observed CDOM in any one of these provinces, and we put that into the equation with this slope. We calculated what we would see if we assumed that slope at 412 nanometers and compared that to the mean ACDOM that we saw at 412 nanometers. And so you can see that throughout the global ocean, you get an error anywhere from about 4 to 20%. And that's strictly from just assuming an incorrect slope value. So that's all I have. Thank you.